Hello everyone. Today we are going to work on developing some simple Suricata rule that is based on a tag that we have captured through pcap file. We will start with the pcap file first. Of course, my setup is Suricata installed on Ubuntu machine, so you might have a different setup. You might want to run this on pcap monkey, for example. What matters is that your setup of Suricata knows where to find your pcap file. We're gonna run it offline, and it knows where to place the logs so that we can take a look at the logs. So this is my pcap file. I'm gonna use Wireshark to look at it, and Suricata setup. I have the logs and I have a folder for custom rules. I'm using Visual Studio to edit the custom rules. That is a simple plugin called Suricata Highlight that would be useful in kind of highlighting different pieces of the Suricata rule that we will create. I'm going to minimize that now as well. So of course I have my biggest reference Suricata rules website. I'm gonna have the link available to you in the description, and let's take a look. So what I usually do, and remember this is very simple kind of threat hunting, but what I usually do is take a look at the protocol hierarchy in statistics. Protocol hierarchy kind of gives you an idea on how much traffic you have of each protocol, and that would help you prioritize. I'm not saying that we're going to ignore things and focus on things. We're just going to prioritize specific protocols because they are more likely statistically to have information about the attack. So looking at the traffic, we can see Ethernet. All of our traffic is Ethernet traffic. Ethernet traffic carrying LLDP, one packet only, which is very unlikely to be the one. We have IP version 4 traffic carrying UDP, which is carrying DNS, and also TCP traffic carrying HTTP, our usual suspect, and ARP traffic. So looking at DNS, HTTP, and ARP, we know that statistically HTTP is the most abused one that might have a clue. I'm not saying that DNS and ARP cannot be used to perform attacks. They do, and they get abused a lot, but we are just going to prioritize looking into HTTP first and then looking at the others. So we're going to start with simple filters: no ARP and no DNS and no LLDP. Okay, so let's take a look at what we have. TCP three-way handshake, and then a get command. Take a look at the HTTP traffic. So we have wordy here. TCP exchange, another get command, another WP admin. So this means that this is definitely a WordPress website. Let's take a look. HTTP, more acknowledgements. Post command, which means that someone is probably logging in. As we can see, URL encoded form, HTTP traffic, and then you can see HTTP stops and we start weird looking traffic at port 8080. If we right click on this and we follow the TCP stream, you can see that this is a reverse shell. So you can see who am I, and then www-data, and then spawning another interactive shell and working with some commands, as you can see. So this is obviously a reverse shell. Now what we will need to look at is what happened before the reverse shell that enabled the attacker access to this reverse shell. You can see it starts here, synchronization request, so this means that it happened somewhere around here. It would be a good idea to look at HTTP requests. So let's take a look. We have 4 GET requests, 3 POST requests. Let's take a look at the POST ones. So this is the first POST, and this is a disaster on its own. You can see the plain text username and password being passed over. Then there is another POST command that is sending nonce and some cookies, which is okay. And then here, this is a weird looking one, plain view activity monitor. So let's take a look at what is being sent here. It seems to be encoded. If you're using tools like Security Onion, you can also decode, or you can just look here, POST, sending information, accept. So this is all the HTTP header, and then the content, multi-part form data. And then we start with the content. It says this is the username. So this is the cookie information. More information, and here it is. NC, netcat command. That's so this, it seems like this is some sort of command injection. As you can see, netcat to the attacker IP on port 8080, which is spawning bin bash. So this is probably the attack that has, this is what we will need to filter for when we create our Suricata rule. So you can see here, this is what we will need. I'm going to minimize this for now. And so in my setup, before we start with creating the rule, I would like to just run Suricata on the pcap file just to make sure that we don't have any rules that are already being triggered. Okay, so my Suricata setup, which is kind of a lengthy command, so I'm going to paste it here. So take a look what we're doing here. I'm telling Suricata where the pcap file is. I'm telling Suricata where is the settings file. The reason why I have this settings file, because it's pointing within this suricata.yaml, it's pointing towards my custom rules file. And then there is where do I want the logs to be placed, and K none, which is basically disabling the TCP checksum, because Suricata would trigger a lot, and we know the checksum issue. It's just tons of false alarms because of the recent settings of TCP. So I'm going to run this now. While it's running, I'm going to show you where the log is going to be. Expect Suricata logs. So it's still running. You can see this is the latest version of Suricata. So we can either go to eve.json, which includes all of the stuff, or you can just go to fast.log for now. Emerging thread policy, clear text WordPress login, which is what we mentioned earlier in our first POST command. And then HTTP client body contains PW, which is, yeah, it's the same issue. So you can see both of them are triggered for the same packet. So nothing's talking about the reverse shell that we just saw. So I'm going to just clean up. Erase these logs files for now. Okay, they are erased. So let's begin. It's a good idea if we want to start gradually by creating, simple things just to make sure that the mechanism works, where, the alert is being triggered, and then we will start narrowing down to make sure that we reduce the false positives as much as possible. Something that we always say about Suricata rules is that you need to focus on the vulnerability rather than the exploit, so that you make the Suricata rule as accurate as possible. We can, I think I have search exploit. Yes, I have search exploit installed. So what I'm going to do, I'm going to look for this plain view activity monitor so that we can get an idea on what exactly is happening. Plain view activity monitor. So you can see command injection. That's basically what we're looking for. We can get some information. Search exploit. I'd like to take a look at 45247.274. Okay, so it's available now in HTML. Take a look. Inspect. This is it. Okay. Oh, okay. So that's basically the whole thing. It's the exploit itself. So let's open it up here. Yeah. Plain view activity monitor WordPress plugin. Vulnerable to OS command injection, which is basically why the attacker was using it for netcat. We can take a deeper dive into what this is about. You can see this is a demo of the exploit, which is very similar to what we have seen. Yeah, this is the NC command, as you can see here. Okay, so now we have some information about it. This is the CVE number. If you want to take a deeper dive into it, feel free to go to the NVD database. You can search for the vulnerability. If you want to get more information about it, I think you'll find it here, and you can see it's 8.8. That's big. Okay, so let's go back to Suricata. So let's start with the simplest format. We're not going to drop anything for now. We can start by simple alert. I'm going to close this, and we will start by simple alert. And the alert, we want to focus on HTTP, not just any TCP traffic. It's bad practice to filter based on the source of the attack, unless the source is part of the indicators of compromise of some active campaign. That's usually when we add IP addresses. The source can be anything, and the direction of traffic from anywhere to, if you have a web server, you can put the IP address of the web server, or you can have home network depending on your Suricata setup. I keep it on port 80 as the destination. I think it's a good idea. And then we can start with the message. What kind of message do we want to send? So for now, let's just start with my Suricata rule. Let's see. Suricata rule 1, and that is the correct syntax. And let's do only this now, okay? I have it saved, and then I will run my Suricata. If you have a problem with the syntax, usually you would get a note here. After you run Suricata, you would get something that says, yeah, exactly. So I have mistyped. Oh, I have 3 HTTP. Okay. Save again, minimize, and let's run this again. Let's take a look at what this looks like now. Okay, it's done, no errors this time. Let's take a look here. Okay, my Suricata role is getting triggered multiple times with all HTTP traffic. So basically that's our first triggers all HTTP traffic. We don't want to do that, of course. That's a ton of false positives. Let's erase the logs and let's go back to the table. So let's start with OS. Let's start doing meaningful messages now. OS command injection using WordPress plugin. For now, let's keep the message this way. Okay, so now we started with all HTTP traffic. We're gonna narrow it down gradually. Okay, so the first thing to do is look at this. This is a post method. So it's not all HTTP traffic. We're going to look into post methods only. So we will start with HTTP dot method, and within the method we're going to look for the content which is post. So now we're narrowing it down to post methods only. Now, of course, that's not enough because that's going to trigger for all post methods. What else? We can take a look at the URI. You can see the URI is plain view activity monitor and tab activity tools. So we can actually use all of that as part of URI. Okay, so we can say HTTP dot URI. What are we looking in the URI? We are looking for not all of this. That's a lot. Let's say this one. You start with plain view, monitor, tab, tools, and that's the URI. We can, of course, it's a good idea also to always test. So I'm going to save. This is supposed to trigger only once. So let's take a look. Okay, it's done. Let's take a look at fast.log. And yes, it's triggered. That's very good. It's not classified, so this will come to the metadata later on. OS command injection using plugin. Okay, so far so good. Now we want to narrow it down because legitimate use of this plugin will also trigger this alert. So we don't want to stop here. What do we want to look for as well? We want to probably look at the content type. If you take a look here, content length, the length might not be very useful because the attacker might use it, an IP address that has a different length, or anything that would change the length. It might be useful to look at the content type. This one, multi-part form data. Also, that would be useful. So let's add that. HTTP dot content type. And within the content type, we're going to look for, what are we looking for here? It is, sorry, I just lost that, what we were looking at. Multi-part / form data, okay. Multi-part / form data. Let's double check. Is this multipart / form data? Yeah. We can also test now, save and minimize, and then we can run it again. Take a look. And yes, it's still being triggered, which is good. It means that we haven't lost the track. Let's clean it up. Okay, what else should we look for? I think the NC, this is important. This would be useful. NC alone, if we look for the content NC, it might be triggered for the wrong reason. So for example, if someone's trying to ping a website that has NC in it, so it might be triggered for the wrong reasons. We can't filter based on IP addresses also because we don't know the attacker's specific IP address. We can look for this, bin bash. But again, because bin bash is triggering a specific type of reverse shell, which is bash shell, there are other types of shells available. So it might be a good idea to look for bin in the content. So we can have http dot no, not content, that's request body. Yeah, I think that's within. If we just want to make sure, there are a lot of HTTP keywords here. Yeah, I think request body would be a good choice. So request body, and within the request body we're looking for /bin/. Again, save and test. So we're waiting for the file. And there is a syntax error. Oh, I typed HTTP twice. Okay. Yeah, that went in twice. HTTP. Save, and we're gonna run it again here. Okay, so the run is done. Let's take a look at fast.log, and still it's being triggered properly, which means that we're on the right track. I think we have enough conditions now to kind of narrow down the triggers. So we might want to start adding some metadata. So usually the first type of metadata that we would want to add is an ID for the rule. So depending on how your organization wants to number them, I would usually use something like the year, the month, and then rule number 1, for example. It's also useful to have a revision number, so that whenever you edit these rules, you add, you change the revision numbers and so on. Another useful piece of information would be classification. Class type, in this case it's web application attack, because that would change the priority and the urgency of the attack by changing the level. Then you can add a little bit more information on why this was created. So you can say reference, our reference is the CVE, and the CVE number that we found is this one. So you can add that. Not here, definitely. Yeah, you can add that here. CVE number. So that would give you enough metadata to review this word drop. Yeah, enough metadata. I'm going to save this, and then we're going to run it one last time and see if we did any syntax issues. And yes. Okay, a typo in the attack. Yeah, web application attack. As you know, these types, classes of attacks are predefined. You can define your own. You can have custom defined attack types, and because these class types would help you, prioritize. Okay, no syntax error. Finally, let's take a look at fast.log OS command injection using WordPress plugin. If we want to look at more details, of course, you can see there's a lot of events. I'm going to search for 2023-0401, and this is it. You can see the information being added. This is our message: category web application attack severity 1 based on the category type, host name, and all the information, the URL, all of the details that were captured here. And that, of course, would also be showing if you're using ELK or any other type, like security onion. That's going to show from your Suricata log. And that's basically it. So just to recap, we're going to walk through this quickly. HTTP, because the attack used HTTP, we did not limit it to a specific source because this attack might be performed from anyone or anywhere. The message we try to be as specific as possible. You can also write the WordPress plugin name if you want. That would be more informative. The method is post, so that we exclude get commands. The URI should include this, and also the HTTP content type is multi-part form data, and the request value would contain bin. So remember, this is OS injection, which means that reverse shell is not the only possible trick that the attacker might pull. They might want to run other types of commands, OS commands. So you might want to think about that, and then always add as much metadata as possible so that you can, because 2 months from now you're not going to remember why you wrote this rule, and it would be really useful to have as much metadata available for you to read on later. Okay, thank you very much for sticking around. If you like this video, let me know so I can, you would encourage me to add more videos like these. And have a great day, everyone.